So here we are. Good evening. I'm Cindy Elder. I'm the Executive Director of the Barrington Land Conservation Trust. And on behalf of our Board of Directors, welcome to, believe it or not, the 7th and the final event in the 2024 Land Trust Learning Series. And tonight we'll be featuring Professor J.P. Walsh and Dr. Victoria Fulfer from your, J.P. Walsh is from URI's Coast Lab, and Dr. Fulfer is from Five Gyres. Okay, I just got this tonight, so welcome. Hi, Kate. How are you? Come on in, everybody. Hey, how are you? Come on in, welcome. It's been quite a week, eh? But here we are, we're together, and we are gathering to grow our understanding of conditions that affect the health of our Earth. I've been reflecting today on the importance of local involvement in the issues which make us a community. This morning, hi Ann. This morning, 3 floors down here in the library, my 94-year-old mother was volunteering at the town museum, as she does every Wednesday. Even though she just got out of the hospital a few weeks ago, she's like, it's Wednesday, right? Going down. And here we are, 3 floors up, thinking about how we preserve our natural environment for future generations. And I think that, for me, symbolized what really happens in a community that cares about each other, cares about what's going on in the world, and we have such tremendous impact at the local level. This is good work, and I look around this room, I see, Gail from the farm school, I see people involved in the Terrapin Conservation Project, people involved in the garden club, all sorts of different things. This is really good work that's happening, and it's work we can do together. I want to just take a moment to consider where we are at this moment, sitting in this beautiful auditorium, in this public library, in the town of Barrington, surrounded by estuaries and salt marshes, fields and forests, and how lucky are we? And we're fortunate to live in the ancestral homelands of the Pokanoket tribe and to hear their voices as members of our community today. My hope is that we will live up to their example, the example they set for us to care for Mother Earth and her inhabitants. I want to express our thanks to the Barrington Public Library and to our leadership sponsors, the Shaw's Foundation and Santander Bank, our partner sponsors, Gunnis Financial Services, Bank Newport, Prickly Ed's Cactus Patch Native Plant Emporium, say that 5 times fast, and Rhode Island Natural History Survey, and our community sponsors. All of them make it possible for us to offer the learning series to the public at no charge. Before I introduce JP and Victoria, I'd like to welcome Representative Jennifer Boylan to the podium to tell us about some legislation currently before the General Assembly. And by the way, we have Representative Boylan to thank for the fact that they're here today, because she's the one who called me after they had a big article in the Providence Journal and said, you really ought to get those people into your learning series. So thank you, Representative Boylan, and let's hear what's going on the Hill.
Thank you so much. Good evening, everyone. I'm really happy that we're doing this this lecture today. Ever since I saw the article in the Projo about the research that shows 10,000 tons of microplastics in the bottom of the bay, I've been really focused on what can we as community and what can I as a lawmaker do to stop it, to make it go away, to stop it at its source, and to deal with what we've got. And so what I wanted to do very briefly is tell you about 2 pieces of legislation that I'm supporting in the General Assembly and that I will be continuing to support in the 2025 session. The first is a bottle bill. This is Representative McEntee's bill that she's introduced several years now. It's a bottle deposit bill. If you've been in Massachusetts, you've known that over at the Shaw's, over at the Stop and Shop in Seekonk.
I'm the worst offender.
Anyway, a bottle deposit. Massachusetts has a deposit. I think it's a nickel. They're about to go up to a dime, and the idea is that you spend a little extra when you buy your soda bottles or your bottled beverages, and you get it back when you redeem them, and you keep them off the streets and out of your beaches and off the curbs and away from your roadsides, because they're worth something, and someone can make money off of them and keep pollutants out of the environment. A bottle bill's been proposed for Rhode Island, a 10-cent deposit, and it's been heavily opposed by, you guessed it, the bottling industry and the folks that profit off of the bottle waste and who have no responsibility to clean it up. Right now, there's a study commission studying this bill. It consists of folks that really are environmentally conscious and want to pass a bottle bill, as well as members of the industry, to try to come together and hammer out an acceptable solution. Right now, that study commission is bogged down over three main issues. First, the industry is unhappy with the cost. They think the cost will give them an unfair advantage regionally, because this extra expense that people will have to spend every time they buy, a 6-pack of Coke or whatever their soda bottles are, or their drinks. Second, there's the bottling industry is proposing more of an extended producer responsibility approach that would be broader than just bottles, so it would expand to all plastic containers and not be exclusive to the bottling industry, which would spread it out. It's really a different beast, right? So we're not finding yogurt containers along the road, we're finding bottles. So it's a very different thing. And then third, resource recovery right now collects bottles up and gets a price, makes money from them in the marketplace from these recycled bottles. And if there was a bottle bill, they would have a budget shortfall because they wouldn't be making as much money. So those are some of the main sticking points that need to be ironed out. And I'm hopeful this study commission will be meeting early in the session in January, February timeframe, in time to hopefully come to conclusion and issue a bill that's acceptable and that we can pass in the next session. The second bill is the Microplastics bill, which was directly inspired by the research of these fine scientists. I proposed legislation that is been championed by Clean Water Action and other advocates that would do two things. It would prohibit intentionally added microplastics from products, and it would also require the DEM to develop a microplastics testing scheme. So that bill was introduced last session. It didn't go anywhere, but I'm hopeful in next session that it will. So thanks for listening to me talk about legislation. If these bills are of interest to you and you'd like to see them pass, please reach out to me, because we need you to come to the State House and testify and maybe write letters and help get these bills across the finish line. Thank you so much for listening.
Thank you so much for coming, making time to tell us about that. Well, now I'm really honored to introduce Professor J.P. Walsh, Professor of Oceanography and a geological oceanographer, who will share his research on microplastics in our environment. J.P. holds a doctorate in oceanography from the University of Washington, a Master of Science in Marine Environmental Science from Stony Brook University, and a bachelor's degree in geology from Colgate University. Any fellow alums from, this is a nice scattering of universities, right? Over his career, J.P. has conducted research around the world, including in the Philippines, New Zealand, Antarctica, and in the United States, and right here in Barrington. So I'm so pleased to also have Dr. Victoria Fulfer here tonight as well, which is exciting because when we first heard about Victoria, she was a graduate student working with J.P., And she's now a doctor, so wow, that's pretty amazing. And she was one of the people featured in that front page article. She's played an important part in this research, and she is now continuing to do research on plastics in the ocean with 5 Gyres, which is a nonprofit organization. And so that is all that I have to say. I'm very happy to turn the mic over to J.P. and Victoria. Ronan, should I turn this off? Should I turn this mic off? No, okay, got it, all right.
Hello, this is like, in the spirit of Halloween, a little treat that we're getting to enjoy after Election Day. So thank you very much for everyone coming out. It's a real pleasure to be here, to have Representative Boylan here. Cindy, thank you so much for your leadership and for your invitation. This is really an honor and pleasure, and what an incredible library you have here in Barrington. So I thought I'd start, you're really getting a 2-for-1 deal here tonight, because I'm going to talk a little bit about storms, coastal resilience, and then we're going to pivot into the microplastics work that really was led by Victoria. I did a lot of some initial sampling and supported her, but she's the real rock star in the room for that work and has been tremendous champion of this issue. So we'll hear more from her in a second. So bear with me while I tell you a little bit about an issue that is probably something you're all aware of, but maybe to get you thinking a little more about it. So I thought I'd start with a few headlines for this talk. 2 from the past, right? We can read from 1920, we can read about issues of pollution in Narragansett Bay. We've had issues over the years, and we've taken up the sort of charge to deal with those problems of pollution. Plastic is a new one that I think we need to be thinking about. Of course, storms have been a big challenge here in Rhode Island and along the eastern seaboard. This fall, we unfortunately had some very powerful events that caused some real issues. And we're going to be talking a little bit about the past, the present, and then we'll be thinking about the future on both of these topics. And you've all probably seen this headline of more plastic than fish. So I start with this picture from Edgewood Yacht Club during Hurricane Carol in 1954. And this is the yacht club literally engulfed by the sea. This was a really powerful event that drove an incredible storm surge up Narragansett Bay. This was because of the incredible winds. This resulted in hundreds of buildings and homes being lost and dozens of lives lost. So this was a really unfortunate, powerful event. And it should be always in our minds some of the risk of an event like this. Shown here is a picture from what's known as Storm Tools, which is an app that was generated basically through research at University of Rhode Island by the Coastal Resources Management Council, which focuses on us understanding our risk to storms, surge, and sea level rise. And in the upper corner there is the position of the Edgewood Yacht Club. And so one thing that Storm Tools can do is it can, using advanced hydrological model, sort of recreate what a hurricane like that would look like today. And so first I want you to just take a picture of this section of our coast here of Rhode Island, and you can see a lot of structures, right, all around Rhode Island. Rhode Island's although we have a lot of rural areas, it's a quite densely populated area, and you'll notice that this is the predicted storm surge from a Hurricane Carol-like event. And we don't need to focus too much on the details, but you can see a lot of hot colors there. That's indicating inundation of water. The oranges are a few feet of water. And what's concerning there is that that's, of course, on top of a lot of structures and communities and infrastructure across our state. So this is a big issue and something that I know communities are certainly thinking a lot about. And of course, you can see Barrington there. I'm going to zoom into this area of sort of Barrington and Warren. And here's this sort of snapshot of an area where we can sort of see structures a little bit more. And then I'm going to quickly add to the map. This is the position of appropriately named Water Street, which unfortunately, in an event like this, we're looking at the potential flood. Now, this is Hurricane Carol was an incredible hurricane, but this could lead to widespread inundation of our communities. So it's something that it's not something we all want to think about, but it's something that should be in our minds as we think about our coastal system. So shown here in the background, you can see an image of a young man looking over the flooded city of Providence. And this is probably unlikely to happen today because we now have a hurricane barrier protecting the downtown Providence. But of course, that hurricane barrier is not at the mouth of Narragansett Bay, right? It's at the mouth of the Providence River, the upper Providence River, protecting the city. So if we think about it, if risk, the simple equation here, if risk is the likelihood of an event happening times the impact, and something I've shown you is that the impact in an event like this is very significant. We're talking about wide-scale flooding. And the likelihood is really low. But year after year, that probability is going to increase because with time, it's likely that we're going to see, it's not going to be Hurricane Carol, but it's likely to be some other system that could cause real impact. Additionally, we have sea level rise, so there's that to consider. So why is this such a big deal? Well, the state of Rhode Island is the ocean state, and we have an incredible blue economy. It's estimated over $5 billion a year is basically generated from this incredible diversity of ecosystem of businesses related to the coast. From our military and tourism and more, we have a lot of connections. And when we have an event like that we're talking about, it can lead to all sorts of complications, both to individuals' lives as well as their livelihoods, and therefore our economy. So one thing that you all, I'm sure, are very well aware of, our coast is certainly more at risk. It was at risk in the past. It's continuing to be at risk. With sea level rise projections, we're looking at something on the order of a couple feet by 2050 of sea level rise. So a storm like Carol would be that much worse in our coastal system. Of course, temperatures and seas are rising. Climate is varying a lot. So what we refer to, a lot of people call it global warming, but I also like the term global weirding, which really captures the reality that it's not just that we can get it's getting warmer, but we're getting all this sort of crazy weather that leads to incredibly intense rainfalls that can be very problematic. And of course, there's the concern of more frequent large storms. And of course, this is superimposed on our more developed coastal system. So one thing we hear a lot about is resilience. And resilience is this idea of a community's sort of ability to bounce back. And I really like that idea, and it's important as we think about our communities. But one thing we should think about when we have a storm event like this is how do we, I don't love bounce back because we might not want to go back exactly the way it was. We may want to understand when we have an event and think through our, sort of limit our vulnerability into the future. So these events are really important to think about change. Additionally, this longer definition from the IPCC, the Intergovernmental Panel on Climate Change, highlights that it's related to the capacity of social, economic, and environmental systems to cope with hazardous events or trends, et cetera. And that's an important definition because it's recognizing our social system and our economic system are very tied to our environment. And that if we experience a trauma like an event like I've highlighted, it could be a real issue. We're starting to see a lot more research and then, of course, news and other media outlets reporting on connections between the social system and our vulnerability. One study there talking about deaths being more concentrated in vulnerable areas. There's lots of work showing power outages last longer in communities that are more vulnerable. And another big issue that we are not maybe always on our mind is the mental health challenges related to climate change, which these traumatic events, especially repeat events for communities, can really raise concern and anxiety for the future. So there's a lot to think about. I know it's a grim topic. We got to be optimistic of what we can do. But I think what I want to highlight here is that when we think about climate change, and we're going to talk about pollution in a little bit, but I think climate change is probably the gigantic issue facing our society today. And many times when we think about climate change, we hear about the risks of drought or fire or flooding. But I think what we really, as this diagram nicely shows, it's the coupling between the community, the vulnerability factors, as well as what's being exposed, our various systems, energy, and so on, that can be impacted by these events and lead to various forms of health outcomes that we don't always think about. So yes, we might be worried about direct injury, but you might not be thinking about the increased vector-borne diseases or other challenges. I know this summer I was a little surprised to get an alert on my phone that they were dropping basically insecticide into our nearby marsh because of EEE outbreaks in South Kingstown. So these are things that are evolving in our coast, and it's especially in our coastal areas where we have this sort of melange of people, infrastructure, water, standing water, all sorts of nutrients and pollutants. So, all right, so I'm J.P. Walsh. I'm gonna talk a little bit about coastal resilience, and I thought I'd give you a little bit of an introduction. You heard about my background, but a little more personal. I grew up in New Jersey, and this is a picture of me on the left sweeping up after a hurricane. And I remember being so excited about that, the traumatic event, the wind, the rain, that I was like, let me go out there and clean up. And it was, and I think that's why I've ended up in the field I'm in. On the right is a picture of me in the mangroves of Papua New Guinea, where I've did my PhD work. And I'm really fortunate to have done work all around the world because it gives a unique perspective to the challenges. We're really blessed here in the United States. And I also think it's really our sort of need to sort of lead the way on many of these challenges. And I don't always think we do in the US. So that motivates me. So the work that I began on was really understanding how mountains erode away and how the sediment from land and of course the pollution and carbon and other things associated with it washes to the sea and accumulates in the ocean, building a sedimentary record. And there's all sorts of things that affect these processes, and I won't go over all that today. But additionally, I've been living at the coast for many years, and that's gotten me very involved in all sorts of coastal process hazard work. And that's been certainly very fun over time. So I'm in charge of what I call the Coast Lab, but my lab's kind of small at the moment. Victoria has graduated and off doing great things. But the lab it has, of course, students in it and collaborators. We examine coastal changes and also work on sharing knowledge with the world. On the picture on the right here is from about a month ago. I was in the Philippines where we were leading some trainings on mapping coastal habitats using satellite imagery and how to do coastal science. So I think this sort of work is important. Additionally, one of the areas where we're emphasized is measuring human impacts of all types, not just plastics, but on our coastal systems. Humans have we often think of nature being in control, but we affect a lot of things. So I want to thank a lot of people, and especially the students that are pictured here. They're the ones that drive a lot of this work, collaborators, staff, funding agencies, community members, and this is supposed to say the Barrington Land Conservation Trust. See, sometimes when you use slides from more than once, you get busted. So when we think about storm events, or disaster in general, we often talk about 4 different phases of disaster management. There's mitigation, it's a circle, so you can start anywhere, wherever you want, but we'll start with mitigation. Is sort of what you should be doing all the time. When you don't have an event, you should be thinking about how do we mitigate against the next one, because we are going to have another event. When we start having that possibility of an event is when we really kick in that preparation, and there's a lot that we need to be thinking about for those significant events coming. After we have a storm event, or as we have one, we're responding, and then of course there's the recovery phase. Most of the work that we are involved in is sort of in this mitigation end of things, educating, understanding our vulnerability, and hopefully helping lead to improvements. And that's, the reality is Rhode Island, as beautiful and wonderful as it is a coast that is dynamic. And these pictures are from Hurricane Sandy. This coastal system is being impacted by all sorts of storms, sea level rise, and of course us, reshaping it. There's been decades of work, and we've learned a lot of great things about how the coastal system works, how the shorelines are eroding, and about vulnerability. But one of the realities is we can't stop learning because it continues to change. There's a lot of complexity that we still don't understand. So that's where some of the work, I won't go through a lot of projects, but I wanted to give you an example of one ongoing project. This is funded by the National Oceanic and Atmospheric Administration, and we're looking at nor'easters and hurricanes and how they impact communities in New England. The project involves doing very sophisticated computer modeling of both water and storm processes, and we're working directly with some communities to understand their concerns and how they might respond to the risks out there. And I won't get into a whole lot of detail here, but I do want to highlight that increasingly, and I think very importantly, many projects are coupling science to in direct engagement with communities or other stakeholders. And this project, we are certainly doing that, led by Pam Rubinoff from the Coastal Resources Center. This is a picture of our group meeting at the Charlestown Town Council discussing some of their issues on their coast. And this project started kind of right around the end of COVID, and we were fortunate or unfortunate to have storms that have been happening since then, and that was not something you can always plan. But the last 2 winters, we've had, as you all are well aware, we've had some really powerful nor'easter, really they were southeasters or southwesters, that caused some dramatic impacts. This is a picture of, at South Kingstown Town Beach, of a wave running up and destroying the dune system. And I'll get back to that in a second. So at the beginning of this project, one of the things that we did was, because the last big storm was Hurricane Sandy, we developed some modeling to model Hurricane Sandy. This is the coast of Charlestown. This is Charlestown Beach Road, and this is the Breachway. And this is a model that's, the cool thing about models, you can make up how much the sea level rise, how strong are the winds, etc. So this was a Sandy-like storm with 1 foot of sea level rise. And I don't know if this is going to work. There we go, it's playing. Oop, I stopped it. So as we zoom in, you're going to see the coast changing. This is sort of as the waves and currents are moving on, the coast changes. You can see that there's a big erosion event that happens here, and there's a breach of the barrier. There's basically erosion of the coastal system. This is the breachway, the navigation channel to the ocean, and that cut across. And what was really interesting about that was literally a year after the project, in 2022, this is the breachway, and we had, during that powerful nor'easter that first picture was from, this happened. The breach cut across, and since that time, water's been flowing into the channel and clogging it up. So we've been working carefully with the town of Charlestown. Just this past week, they've been doing an emergency repair at that site to help sort of secure that navigation channel and to some degree really help protect the town for the long run. Additionally, this storm system caused really significant erosion along the South Kingstown shoreline. Shown at the top is a picture from November 10th, and to help you out, I've kind of traced in the vegetation boundary there of the beach. And then just a couple weeks later, this underlying picture is a drone picture that we took, and you can see that we've eroded the coast. This is a very high coastline, about 20 feet. And it eroded so much in this area that there was what we call overwash of water and inundation of the adjacent community, which led to the blocking of Matunic Beach Road and flooding of this largely vacation sort of home community. But nevertheless, emergency personnel never like to see a road impassable. This is a road out to a community that was blocked for a while, and obviously this is an unfortunate reality. So these are, you know, sort of the situations that we're seeing more and more in communities all around our coastal system, and there's a lot of work to be done. I also wanted to mention, last year I was here with my Christmas hat, as we heard about, my Santa hat, and we were doing some work to understand how the marshes in Barrington, as well as a few other marshes in Narragansett sort of Bay, have been changing. And I won't go over the whole study, but we, as part of the work, my student, Dasan McElroy, his thesis studied 4 different systems. 2 of them were in Barrington, the Pickwill Nature Preserve and Allen's Cove Conservation Area. And what we did was we went out and collected a lot of data. We used a GPS to measure the elevation and used that to understand how the marsh is distributed. We also did mapping of the shoreline using historical aerial photos to understand shoreline changes in the area using different time windows. Also, we took some cores and we dated the cores to understand how the sediments are building up in the marshes, and examined some elevation and what we call SLAM model data, which I won't talk about. But additionally, we did similar work, as I mentioned, here at the Pickwill Nature Preserve. So the previous one was Allen's Cove, and you can see the shoreline data, the transect, and more. And I'm not going to go over the whole thesis, but one of the take-home points here that I'm sure you're all concerned with is, and have seen, that these marsh systems, these are small marsh systems, relatively speaking, but they're really important ecologically, especially in the upper Narragansett Bay, where wilderness is becoming increasingly less and less. So that was really our motivation for the study. And what you can really see here is that the shorelines are either eroding or are very dynamic in these areas, and that is threatening many marshes. We do have some measurable accretion of these marshes, so it does look like they are, at least from the limited data that we got, they are keeping up with sea level. But of course, if erosion comes along and takes out the marsh, that will be the end. So I guess what I'm trying to highlight here is there's a lot of natural dynamics, especially in these small coastal systems. And the other challenge, of course, is that there's development, which, you know, we're a community here, and these marsh systems we value and love, but of course that restricts them for their future. So they have like sort of a limited expansion and life, and that's something that we need to be thinking about ecologically and environmentally. So with that, I'm going to pivot to Victoria and hand it off to her.
Great, thank you, JP. Hopefully you all can hear me all right. So as JP mentioned, I was a PhD student with him at the University of Rhode Island, and I moved up here to Rhode Island from Pennsylvania in 2012, absolutely fell in love with the area and decided to stay. So I got 3 degrees at the University of Rhode Island, and now I work at the Five Gyres Institute, which is a nonprofit organization. We do work all around the country trying to do deep research into microplastics in the environment and in the oceans, come up with solutions, and then take them to Congress to come up with policy solutions as well. And so I'm here tonight to talk about plastic pollution, a problem that is absolutely global, but also really impacts our communities right here in Narragansett Bay. So as I'm sure a lot of you are aware of, we have been increasingly producing plastic since about the 1940s. And as we produce more and more plastic, a lot of this has become plastic waste. And what I really focus on is mismanaged plastic waste, which is this part right here. So even though we're producing about 270 million tons of waste every year, about 30 million tons end up becoming mismanaged. And mismanaged waste is waste that doesn't make it through normal waste streams. It's not making it to a recycling center or a landfill. It's ending up in the environment. And once it's in the environment, often it ends up in our coastal areas because that's where we have a lot of our world population. And about 8 million tons per year are ending up in our oceans. However, when we go out into the ocean waters and measure the plastic in the water, we're only finding, tens to hundreds of thousands of tons of plastic. So where is the other millions of tons that are missing? And it turns out that they're in the sediment. And so I focus, and as JP mentioned, he focuses on what ends up in that sediment. And what's in the sediment is not just large pieces of plastic, but microplastics. So microplastics are small plastic particles. They are sometimes manufactured to be this small, and other times they are broken down from larger items. So they can be anywhere from 1 micron in size up to 5 millimeters in size. And this is a really wide range. So here you're seeing an image of plastics found in the sediment of Narragansett Bay. And these are all ones that you can see with the naked eye. They're all larger than 1 millimeter in size for the most part. But a lot of what we're finding is much, much smaller than that. It's microscopic, and you can't see it. And we are finding ones that are so small that they're down to the size of a red blood cell. And so we're looking at a huge range in size of these plastic particles. And plastics are incredibly complex. So when we're thinking about plastics, we're not only thinking about what shape or size they are, but we're also thinking about the different polymer types that exist. So we have, at this point, dozens of different types of plastic, and all of them act differently. All plastic products have different additives that make them the products they are. They make them more flexible, a certain color, flame retardant, different things like that. And then, of course, they're coming from different places, which means they're shedding into our environment in different ways. They have different shapes and different colors, which impact how they interact with biota, if biota are going to ingest them. And then, really importantly, plastics in the environment are not just inert, they're not just floating around. If there is another toxin that is nearby, they have been shown to absorb that toxin is going to attach to the plastic, and then if that plastic is ingested, so is the toxin. And so this makes plastics incredibly complicated to study in terms of their impacts on the environment. And increasingly, we have more and more sources of microplastics to the environment. So this diagram is showing some of those sources. So we'll start with our land-based sources. The most common one we think about is litter. So of course, plastics that wind up on the streets eventually will break down and end up in the environment. But we also have personal care products that have microplastics purposely added as abrasives. They're coming off of our washing, off of our clothing when we wash and dry them and wear them every day, because much of our clothing is made of synthetic fibers. And then, of course, they're also coming off of our roads because tires are made of plastic particles and they're constantly shedding those as we drive around every day. But we also have marine-based sources. So things like boats and fishing gear are shedding microplastics. And then, of course, there is marine litter that ends up in the ocean and then breaks down once it is there. Something I focus a lot on now in my current position is also air-based microplastics. They're not in just in our water or in our soil. They are in the air that we're breathing, inside and outside. So they're in the dust that's in our air as we shed them from our carpets and our clothes. They're in the city dust and the dust coming off the roads and buildings. And once they're in the air, they're able to be transported all around the world, which is why you could take a sample from a very pristine, remote area, untouched by humans, and still find microplastics in the soil. And this can have a range of impacts, and I'm focusing today mostly on the impacts to aquatic ecosystems because we're talking about Narragansett Bay. So as we have more and more microplastic concentrations getting higher and the plastics are getting smaller, they're impacting a wider range of trophic levels. So not just the big fish, but also the very small plankton. And so we have macro debris that is impacting things like sea turtles and whales due to entanglement. And then we have the microplastics, which are small enough to be ingested by, of course, fish and other organisms, but also zooplankton. These images are from a study that I did using samples just off the coast of Narragansett Bay on the northeast shelf. And these are single-celled zooplankton, the smallest predators of the ocean that have ingested plastic particles inside of them. And the ingestion of these particles has a wide range of impacts for marine organisms. It causes inflammation in the body and stress, but it also causes a huge range of effects, including DNA damage, reduced growth and reproduction, and endocrine disruption. And so even though the research into the impact on human health is very new and we don't know a lot about what the impact to us might be, the fact that we're seeing these impacts in such a range of marine biota should definitely be setting off some alarm bells that if it's impacting them, it likely is having some kind of impact on us. My work focused on Narragansett Bay. I'm going to walk through two studies. I'll really briefly mention the study that brought me here today, and then I'll go into a new study that has not yet been shared, both of which focus on Narragansett Bay. So our first study on plastics in the bay focused on shoreline sites, those are these yellow dots here, and some bottom grabs from the bottom of Narragansett Bay looking at how much plastic was in the sediment. And you might be wondering how we're able to look at these small particles. So what I do is I take sediment, and if there's a lot of organic matter in it, such as if it's coming from a marsh, then I will do a digestion, get rid of all that organic matter. And what's really nice about plastics is they're really light. So they float and sediment sinks. So if you put them in a dense solution, then the plastic will float to the top and you're able to filter that out. We're able to then look at those filters and understand the size, the shape, and the colors of all those plastic and how much is out there. But then we're also able to use a really cool technique called FTIR, which uses lasers to tell us exactly what kind of plastic we're looking at. So you can think of FTIR like a fingerprint for every type of plastic. And so this is a scan of a filter from Narragansett Bay. All of these are different types of particles, but we don't yet know if they're plastic or not. So we have to use that fingerprint. So this black line is what polyethylene, a type of plastic, should show up as. And the red line is what one of those particles showed up as. So when they match well, we can say that that particle is that type of plastic. And that's really important because different plastics have different impacts on biota. So what did we find? These sites are ordered from the north to the south. And so we have some northern sites up here near the mouth of the Providence River, going all the way down to the Narragansett Beach. The blue bars are samples that were taken from the shoreline or the beaches, and the orange bars were taken from the bottom of Narragansett Bay. So what you might notice first is that we have this down system trend where we have really high concentrations near urban areas, and we have less and less microplastics as we get towards the mouth of the bay. What we also find is these concentrations are incredibly high, but they're even higher on the seabed than in many cases on the shorelines because these plastics are in the waterways and they are sinking out of the system and being deposited at the bottom of Narragansett Bay. So I'm not going to go into too much more detail about this study, but one thing that we did was we were able to model, based on what we found, how much we might predict is in the bay. So when we sampled the beaches, when we sampled the bottom of the bay, we were looking about the top 5 centimeters. We weren't digging very far down. Those top 5 centimeters were probably deposited within the last 10 to 20 years. And if we model how much is there, we're finding about 1,000 tons of microplastics in that top 5 centimeters of the bay. And this is really important because microplastics weigh almost nothing. Even if you take a large amount of sediment and you filter out the microplastics, it's only a few grams at most. And so to reach 1,000 tons of these microscopic particles is really amazing. What we're also finding is that about 50% of them are trapped in this upper area of the bay. And this makes sense because this is close to our urban centers. We have more people living there. We have a lot more runoff. And we also have a lot more wastewater treatment plants, which can be another source of microplastics because when we wash our clothes, they wind up in our wastewater. But what I'm really excited to share with you today is a new study that hasn't been shared out before. And this is looking at not just what we have today, but how we've gotten here. How have we accumulated these microplastics in the bay? And so to do this, we take sediment cores. As you go deeper into a sediment core, you're going back in time. And so there's sort of a time capsule of how much we polluted each year. So these dots are sediment cores that we took. The red dots are just subaqueous sediment at the bottom of the bay. And then we have 3 marsh cores, one just south of Providence and 2 down here near Jamestown, because I wanted to understand how the marshes were trapping plastic as opposed to just regular sediment. So let's walk through what we can learn from a sediment core. You don't have to understand radioisotopes, but we use lead-210, which is a radioisotope, to understand how old each layer of sediment is. So we take the sediment core and we cut it into these different sections, and by measuring the radioisotopes of each section, we know what year it was deposited. We look at grain size, which is just the size of the particles in the mud, and that tells us something about the energy in the environment. And then, what you probably care about, we look at the microplastics. So this is just one example. And so we measure the microplastic concentrations in each layer, which are correspondent to the year that they were deposited. So back when we first started using plastic products, we have incredibly low concentrations in the core. But as we increase our use of plastic products, particularly towards the modern day, we're seeing this exponential increase in the amount of plastic we're finding. And not only just in the amount of plastic, but we're seeing an increase in the diversity of the plastic. So these are the same numbers, but now colored by the type of polymer, the type of plastic. So what we found a lot of is polyethylene. This is a really common polymer that is used in bottles and single-use plastic products, so it makes sense that we're finding a lot of it. Another common thing we like to find is polystyrene, which is that light foam. And so we're seeing an increase in the amount and in the diversity. And we're seeing this everywhere we look. So here, we have the microplastic concentration through time. So these are 2 cores in the proximal zone. So that's that area up near Providence where we have a lot of urbanization. And we're seeing incredibly, incredibly high concentrations as we make it towards the modern day. When we compare that to cores that were in the distal zone, so down near the mouth of the bay where we have more rural areas, we have much lower concentrations. They're still increasing exponentially through time, but they're much lower than what we find up near the cities. But what was really different and concerning was the marsh cores. So these are the 3 cores we took from the marsh. This pink core is the core that we took from near Providence. You might notice that on the seabed, the most we found near Providence was 7,500 particles in a kilogram of sediment. Just south of that in a marsh, we found 30,000 particles. So these marshes are trapping 10 to 50 times more plastic than the nearby seabed. And interestingly, these 2 blue cores from the marsh were from down near Jamestown. So this isn't near an urban area, but because of the trapping efficiency of marshes, they're still reaching much higher concentrations than anything on the seabed. So another way we can think about this is think about how much has accumulated in these cores over the past 100 years. And so here's the accumulation in 100 years. These are ordered from north to south, and the ones that have the little plants on top are the marshes. And so you'll notice that they are higher, they have accumulated more than all of the other sites, and that we have increased accumulation near the city, near the cities, getting lower as we move towards the mouth of the bay. So we know that microplastics accumulation is changing based on time. So we used to pollute less, now we're polluting more. We know that it is varying across space. So if you're closer to sources such as wastewater treatment plants and cities and urban runoff, you're going to have more deposition of microplastics in the estuary than if you're in a more rural area. And they really vary by environment type because marshes are really unique ecosystems where they lower the wave energy, they allow these particles to be deposited, and then they are trapped within the root systems of these marshes. And if I redid that model that I showed you earlier, where we found 1,000 tons in the first 5 centimeters, if I redid it for the past 100 years, that number would grow to 2,700 tons in the sediment of Narragansett Bay. But my favorite result from this study was this one. So here we're looking again at the different polymer types. So each color is a different type of plastic. And we're looking at how they change through time in the bay. So at the beginning, we had low concentrations of plastic and only a couple different polymer types because we hadn't invented some of these plastics yet. as we invented more plastics, we see them preserved in the sediment record of Narragansett Bay. And so by the 1990s, we have a huge amount of plastics, and today, even more. And so it was really cool, depressing, but cool, to see that we can see our evolution of plastic use in these sediment cores based on the types of plastic that we're finding. And so far, what we've talked about is that we have knowledge that the seabed of Narragansett Bay is accumulating microplastics, and that it's going to keep accumulating microplastics. And this could have implications for the life that's living in that bay. We know that the marshes are trapping more than the nearby seabed, which is great that they're trapping it, but bad because marshes are such vital ecosystems for so many biota. And then finally, we know that the diversity of plastics has been increasing over time, which complicates how we study the impact it's having. But what impact might it be having? This is a relatively new area of research. Ecotoxicology studies for microplastics have not been done until the last decade. But one number that has been determined is this 540 particles per kilogram. So that we call this a threshold for harm. So if you have an area that has a higher concentration than that, then it means that at 5% or more of the species in that ecosystem are negatively impacted by microplastics. And so what would it look like if we applied that threshold to Narragansett Bay? These are all of the sites that I have studied, and they are colored by their concentration. So anything that is green is below that threshold of harm. The species in that ecosystem are not currently at risk. But unfortunately, we don't have a lot of green. We have a lot of yellow, orange, and red. Anything in those warm colors is above this threshold for harm. And some of them are 10 times higher than threshold for harm. So this means that in most areas of our bay, we are above that critical threshold, and we may be seeing negative impacts. And so we really need to push for systems like the EPA and NOAA to look into this and to figure out if these negative impacts really are happening, particularly in this proximal zone where we have huge concentrations continually being input every day. But there is a little bit of hope here, and that is all of you, because Barrington is kind of unique. So this is a natural estuary that doesn't have any urbanization. So if we were to go to a pristine place, we would still find some plastic, because some plastic is coming in from offshore or it's being deposited from the air. But we have systems such as marshes, which are these brown areas, and beaches, which are the yellow areas, that can trap some of that plastic so that it doesn't make it back out of the estuary. If we start urbanizing an area, we're creating more sources of plastic, but we still have some of these marshes and beaches that can trap that plastic so it doesn't make it into the open ocean. And an example of one of these places is Barrington. Barrington is uniquely located just within that proximal area, but while there is some development within this area, you still have a lot of green space, you have the marshes, and so you are able to trap this plastic. So conserving those green spaces and those marshes is really important to make sure that that plastic does not continue to propagate down the system. But of course, if we keep urbanizing, we're going to keep funneling plastic out of the bay and into the open ocean. And once plastic is in the open ocean, it's incredibly difficult to deal with. So dealing with the problem here is much easier than dealing with it once it's out there. And so just to reiterate, while we continue to increase urbanization and hardening of our shorelines all around the world, as countries continue to develop, we have to think about the impact that's having on plastics and how we're funneling them out of our coastal systems and into the open ocean, and what impact that might be having on the biota. And so I'll summarize for myself and JP, but we talked about how the coast is really valuable and it's becoming more and more at risk with the changing climate. Plastic pollution is increasing rapidly with no end in sight. And we are trying to draw hope from the fact that communities like yours are taking action and trying to make sure that proper policies are in place to keep our coastal communities safe. Thank you so much.
Thank you so much. Yikes. I'm going to put this mic on and run around for people who have questions.
That was supposed to be a happy talk, but it turned out sort of sad. Sorry.
Hi, in the case, is this working? Doesn't sound like it.
Check 1, 2. There we go.
In the case of the Exxon Valdez disaster, it was found later on that there were bacteria that would consume these large hydrocarbons that were characteristics of crude oil. I'm curious whether any forces or active bacteria, chemical reactions, or even ultraviolet light that will act to break these down over time. Are there such naturally occurring forces, or?
That's a great question. So yes, there are some bacteria that have been shown under very specific conditions to biodegrade some plastic, but it happens very slowly and they only exist under very specific conditions, so they're not out in the environment eating the plastic, unfortunately. Plastic is degraded by UV light, but it just causes it to become smaller and smaller until we reach nanoplastics. It won't actually completely get rid of it. And so that's a big problem. But there are a lot of companies trying to work on ways that we can somehow break down this plastic, whether it's in the environment or in recycling plants.
Since all those plastics are supposed to float, they sink to the bottom and get in the sediment, and they also get vacuumed up by the marshes. Is there anything we can make that's synthetic to duplicate that kind of sequestration that we could put out there to vacuum up the bay, so to speak?
My favorite question. My big pet project right now is floating wetlands. Floating wetlands. So these are wetlands that you can tether to a dock, or that can be anchored in the middle of a river or the bay, and as the water flows past them, they will trap the microplastics. And so this is an option. You can also expand natural marshes or seagrass beds to help collect more of the plastics. But yeah, I think floating marshes, particularly in urban areas and ports, would be a really great way because they trap the plastics, then you harvest the marsh and replant it. And so you're just continually removing the plastic.
And just to add one thought there, that I think we should think about too, that just like we clean our streets, we should be thinking about having programs where we clean our coasts, and not just the macroplastic, but there is value in having boats. So several major cities have invested in vessels that will go out and sort of rake up the sea, if you will, capture that debris and then remove it from the system. I know it sounds kind of crazy, but when we're talking about the amount of load of material that's coming off of our cities, that's sort of our best opportunity to capture it before it gets further down the system. And I'm sure you'd love it here in Barrington if you were getting less. And so if the city could do more, of course, that's not going to trap everything. You're not going to have, when you have big storm events that can really flush a lot of water through a system, that's when we get lots of advection. But anyway, we need to be thinking a little bit more about being proactive in that regard.
Thank you very much. That was a really great talk. Curious about the plastics that you found. So you found mostly polyethylene. So polyethylene is not. It is a little bit now. Sorry, it's a trend, but so it's mostly going to be coffee cups. Coffee cups are coated with polyethylene. Polyethylene bags. So it's not coming from your clothing, and that's the majority of it. And there's a lot of worry about laundry washing, right, and coming from your clothing. So maybe a lot of that's getting captured already in the municipal waste treatment facility. Second question is, and I saw from your map, I thought you said the majority of the microplastics were actually coming from tires, or there was like a large fraction coming from tires, and I didn't see any rubber on that list of particles. Where is that?
Great questions. I'll start with the tire rubber question. So unfortunately, the method that we use to analyze the type of plastic, the one type of plastic it cannot see are tire rubber particles. So we would have to do a whole separate method for those. So that's very unfortunate that we're actually not able to identify those with FTIR. We would have to use a mass spec and do something separate. So that's one downside of the method we use. For wastewater treatment and fibers, two things. Some wastewater treatment protocols do remove a lot of those fibers, which is great. But I think another reason why we're not seeing as much PET and those polyesters is that they are biofouled less, and they typically are less dense, and so they're not sinking out as much. So I think we're finding a lot of those when we measure out in the open ocean. We're finding a lot more PET than when we're measuring in the sediment. And so I think they're just not sinking out as much. I don't think it's a matter of them not being there at all.
PET is denser than polyethylene. It's denser, it'll sink more.
But it has a high surface area, so that's where, even though it may be, I mean, so right now we're running this great experiment of all sorts of types of both polymers with varying density and varying shape and size, all of which is going to affect how they're going to interact with the environment. And so, it's fair to say that when our study came out was like one of the first studies that had a number of samples across a system. And Victoria did a tremendous job characterizing it as best we could. But we really need more work across coastal systems and in the ocean to understand sort of that sort of whole diversity of particle and how they're ending up across that seascape, which is, I think there's a lot more that needs to be done. Of course, ingestion's another possibility along the route, and lots of other sort of trapping mechanisms that maybe we may be sequestering things in certain places.
Thank you. It's a great talk. Is there any effort with private citizens and community governments to work together to get access to some of these shoreline areas for cleanup activity? We get a lot of people that walk the beaches with plastic bags and that sort of thing. But there's, I think, opportunities for private industry and government and private individuals to work together if we have a clearinghouse that would help schedule cleanup events, that would build awareness with our local populations, that would give them, controlled access to certain sites that they may not be able to get to because it's private property or they have access issues. And then the people can get in and see the effects of what plastics are doing on this shoreline, and then work with the government to clean it up and transport the plastics away. Is there any coordination facility or sort of FEMA-type organization that would put those three components together and work as sort of an army of shoreline cleanup?
Well, so, at the government scale, there's the NOAA Marine Debris Program NOAA is really taking a leadership role on the marine debris side, but I would say there's not enough dollars. There's been more investment this year, and so it's good to see a strengthening of that. There's more coordination happening at sort of a regional scale, and then there's the International Cleanup Day, which is a big day, of course, of lots of cleanups. But my general impression is that there's a scattering of events, and any more you want to add?
Yeah, no, I think it's a really great idea. I think one of the issues is that we clean the same beaches over and over again that have easy access when we do these large cleanups, and we're not cleaning these private areas and these areas that we can't get to. And so I think if there was a way to do it, it'd be great. I don't know of any coordinated efforts. I know Save the Bay tries to do quite a bit of cleanups in the Providence area, so they might be someone who might be able to get access to more of these hard-to-reach places.
And just one other thing to add to that is that it's not only that the cleanup's not coordinated, but understanding the problem's not coordinated. So the science has been really hodgepodge with different methods being used in different places. We don't have a very good system scale understanding. I do want to highlight here that Victoria and I are part of a newly funded NOAA program, which is going to be doing the first ever sort of national assessment of marine debris. It is an exciting project. It's being led by a small company called At Orchard, and we will be sort of leading the measurement of our coastal system in basically New England and the Mid-Atlantic. But that study is focused on macro debris. We hope to add a microplastic component to it, so we could at least look at the shoreline sediments and understand that. And if anybody's really eager to find support for something like that, we would love it. But that right now it's sort of an idea, and we're going to collect a lot of samples and hope that we can get a better picture, at least in our region. And we're hopefully, because we're partnered with all the other regions on this with this business, we're hoping to get other areas that will hopefully collect samples as well. So there's still a lot of unknown questions, but I think you're totally right. We don't need all the science to say we should be doing something, and I think that's certainly been our message.
Hi, I just have a question. You showed on the screen how the microplastics create these very small molecules. My question is this affecting, I would think it would be, all the sea creatures that are eating off the bottom of the bay floor and our fish? And I was just wondering if you could address, have you studied how it's affecting our food chain and how much of this plastic we're ingesting and what kind of diseases it could cause? I heard cancer, but you know, just a question in reference to our food chain. Thank you.
Of course, yeah. I think that it's a really big concern for particularly benthic organisms that are in and on the seafloor, as well as filter feeding organisms such as oysters and shellfish that are, filtering the water right near the seabed. So it is a real big concern there. There are a lot of scientists looking at that. The only food chain studies I have done was looking at zooplankton, which are at the very bottom of the food chain, and I did find that they grew quite a bit less and reproduced slower. So that is concerning for impacts above, as we move up the food chain, and there's been a lot of work on that. But in terms of how much we're ingesting from our seafood, I think it's very little based on this information we have right now. A lot of it remains in the gut, which we don't need in most organisms. But there is still, of course, a risk there. But it's also been found in our tomatoes and everything else we eat. So I wouldn't say that seafood is going to be the first thing you should give up eating. There's definitely other things it's in. But it is a concern for human health. We just don't know yet what it's going to be impacting. There are researchers at URI, Dr. Jamie Ross, who's looking at the impact on the brain and looking at dementia-related impacts. But I think it's going to be a while before we really have solid answers on the human health front.
Yeah, just to add one thing to that, which is, a lot of times when we give this talk, people ask about seafood, and seafood's still very delicious and good for us. But it is something that we should probably be monitoring our seafood. But it's important to note that plastics have now been found in all forms of protein that we eat, as well as she mentioned, tomatoes, salt, beer. Beer has some high concentrations in certain, obviously drinking water that you've heard a lot about. And then, of course, it's also been found in pretty much all organs of the body, blood, babies. We know it's throughout, and what where the science really needs to go. And the event that I was at Brown was really, doctors that are like, we need to learn more about what this is doing in so many ways to our body.
If I understood correctly, not all plastics are created equal in terms of their deleterious effects, either because they bind to things that are worse. Can you categorize or subcategorize these plastics into those that are the absolute worst? And would it be possible to eliminate those by legislation, and alternatively use the plastics that are not as bad? Not the ideal way to do it, but a first step.
That would be a really great first step. There has been a lot of research trying to figure out what's the worst. One of the hardest things is that plastic companies don't often release all the information about the chemical makeup of their plastics, and so we have to, as scientists, have to kind of work backwards to figure out everything that's in it. They're very protective of their different products. And so it's a little bit difficult to say all polystyrene is the worst or something like that. So
Yeah.
I think there's an opportunity there, but it would definitely be very complicated in terms of legislation, I think.
And yeah, to add from PFAS studies where they have banned certain PFAS, right? New polyfluorinated compounds have been developed that are causing new problems. So this is where, is the devil we know good, or is the one that was going to be created tomorrow worse? We don't, there's a lot of questions. Sorry, there are a lot of them.
Can I just comment on this one? The worst thing is the rubber. The rubber has terrible carcinogenic antioxidants, and it has aromatic oils. So it'd be good to find out how much is there.
Oh, it's everywhere. Mm.
Yeah, can the sewage treatment systems do anything to capture some of this plastic? I mean, they've been very successful reducing coliform bacteria, nitrogen today. Can anything be done at that point?
Yeah, that's a great question. I think there are methods that are being tested on a small scale right now. The longer they are in some of the retention tanks and things like that, the more likelihood that they're going to be sequestered in the sludge. One kind of area of concern is that we often will take our sewage sludge and it is applied to the land. And so then we're just putting them back into the environment. So I think we need to think a little bit about, is there a better way to separate them from that? But yeah, there's definitely a lot of research going into figuring out how to make it so that wastewater is removing them and we're not just entering them into the environment. And wastewater does remove some microplastics, for sure.
Thank you. I've read about filters in, they talked about putting filters in washing machines to kind of trap some of the plastic that's coming off clothing. But then I heard industry is fighting, and that it wouldn't be a big fix, but there's pushback from industry.
Yeah.
Can you speak to that?
Absolutely. So my company works on washing machine and dryer filtration studies. So we're about to publish a paper about washing machine filters. And they do reduce the emissions. There is a huge pushback from industry. We focused on having them installed in laundromats, which perhaps was our mistake because all the laundromats were like, absolutely not. But you can buy them for your personal machines. And then I just completed a study on dryer filters, which work really, really well, and are also something that you can add directly to your machine. So I think what we're going to try to push for now is getting those more prominent on the market, making it so that people know they can install them to their machines and they don't have to get a whole new machine. And then maybe down the road we'll be able to target laundromats.
Just one question. So I didn't even think about dryers, but is it because it goes into the air, so you're trapping it rather than it blowing out?
Right, yep. So your lint trap only traps some of the filters, and then the rest ends up being blown outside, for most dryers anyway. And so, yeah, it's a big problem.
The core balls that are supposed to trap some percentage of the small fibers, are they effective?
They are effective. They're not 100% effective, but they are effective. But what's most important is then how you dispose of what they trap. So I learned that a lot of people were washing them in the sink and then they're going into the waste stream anyway. And so definitely put them in a trash container and not down the drain. But they definitely are effective. Yeah.
The whole ball?
I think you can remove the fibers that it captures and just throw that away and then reuse the core balls. Yeah.
We occasionally hear about the companies working on biodegradable plastics. I'm curious what your opinion is. That they just break the plastics down into microparticles, which are essentially the problem, or they break them down to monomers, or what's your view on this as the possible solution to some of these contamination problems?
I think it's a promising future solution, but we're not quite there yet. Some biodegradable plastics or bioplastics can be degraded so that they're no longer microplastics. They will be, their original chemicals, and so that would be good. But a lot of them that are saying they're biodegradable really aren't yet. And so I think as we move more towards these bioplastics, we need to think about having policies and legislation in place to vet products before they enter the environment to make sure they're really degrading and that they're not degrading into anything just as harmful as plastics.
Thank you. I noticed the chart that showed the different varieties of microplastics really escalated right around the Afghanistan and Iraq war. So there's a lot of evidence that these national institutions were set up as false light institutions for these work programs that have been existing. And I just wonder if there's local efforts to overshadow these nationally funded programs that I think are actually part of the reason we don't have a permanent solution to this issue.
I think that's a good question. That's a deeper question. I don't know that I would have a good answer to. You know, there's a lot of forces at work in our society, both government and industry and us, and how that drives what's produced, where it ends up, is complex. And so, you know, we can't say yes, no, or anything. But I think it's hard to, yeah, it's a tough one to answer.
Any other questions? Oh.
Pushback by the industry. Is there any way, or would they even consider, probably not, bottom line network, net profit, that they would alter their formula? And what do we do about it? We go to the market, everything's plastic. Some people don't recycle. So is there an alternative to this plastic packaging?
I think there are alternative solutions. I think, you know, grassroots efforts to really think about where you're buying your products and how they're going to be packaged is really important, because if people start avoiding companies that are overusing plastic packaging, then those companies will have to adapt. And so putting that societal pressure on them to say, we don't want our food to be wrapped in plastic, our packages to come with unnecessary plastic, things like that is really important. You know, there's a lot of small businesses that are working really hard to have sustainable packaging and sustainable products, so supporting those businesses and lifting them up, and hopefully will show these larger corporations that there's this green movement, and maybe they'll think, oh, we'll make even more money if we sell something sustainable that people want to buy rather than these other products. So, you know, local efforts are still really important, and so are personal efforts. You know, we can't change the fact that not everybody will recycle and not everybody will avoid plastic, but, you know, changing our own habits can still have an impact.
When our plastics go to be recycled, how would they get away with it? Do they burn them?
Here in Rhode Island, we do recycle some of them. The national average is only about 5% of plastic is recycled. So it's not very good, but there are some places that do better than others. But yeah, recycling is definitely a big issue in terms of the fact that it's not equal everywhere, and we're not always recycling what we're collecting. Yeah. Yes.
Couple of questions. I'm curious about the evolution of a large piece of plastic. And does that large piece of plastic that we might want to pick up on our beach, does that become microplastics? How long does that take, and what's the mechanism of that? That's question number one. And the other question was, are the microplastics mostly from macroplastics, or are they products of industry that start out as microplastics? As an example, I had a dental exam where a dental hygienist with her little magnifying glasses on looked at my teeth and said, oh, you can use Crest toothpaste. Crest toothpaste is just filled with these little micro particles. She said, why don't you switch to a brand? Can you comment on that?
Absolutely. Yes, your toothpaste and many other products do have a lot of microplastics in them. It has Science has shown that a lot of the microplastics in the environment are from the big breakdown of larger products. There is the input of the ones from our cosmetic products and things like that, but with increasingly prevalent microbead bans in Europe and in California and other places, we're seeing less and less of that, and we're seeing companies adapt to remove them from cosmetic products. But the breakdown of plastics, you asked about how that happens. And so, for example, if a water bottle is on a beach, that plastic is going to get more brittle from the UV rays. So the UV rays impact the chemical composition of the plastic and cause it to become more brittle. So it'll start to break down in that way. But the interaction with the seawater also increases the breakdown. And then there's kind of the mechanical degradation as it washes on shore or goes along the seabed. So there's a couple different factors at play. But even large plastic products that are in the environment will eventually break down to only be microplastics. The timeline of that depends on where they are and what kind of conditions they're in. You know, it depends on sunlight and temperature and all of these things, and also the type of plastic. You know, if it's a harder plastic or if it's a softer plastic like a film or a foam, those break down much more quickly. But then once they're in that microplastic phase, it takes them a lot longer before they're even smaller.
I'm going to ask a question. So the issue of synthetic turf has been a big issue in our town lately, and where does that fit into all of this?
Yeah, turf has been a big issue globally, particularly in developed countries. You know, it is plastic grass, and so as you know, it rains, and you know, as people are running around on the turf, it sheds these plastics. They often are also lined with these little black pellets. If you've ever been on a turf field, you might have noticed them. They stick to you. Those are all plastic, and so those often are also being washed away off the fields. And so they are being banned in a lot of countries in Europe, and I'm hopeful that the U.S. will start to follow suit, because it's just, you know, the carbon footprint of them, and there's really just nothing positive about turf fields, in my opinion.
Thank you. Let's see, anyone else who has a question?
You were mentioning that in the marsh, it just really, it's very dense. I mean, the microplastics are very dense. And all different kinds of debris get caught in there. And I've just noticed that sometimes walking on the beach, if you're picking up trash, it's easy to pick it up when it's on the beach. But then when you go back where the grasses are and in the marsh, it's almost like you don't even know how to start, because it's all tangled up or it's so tiny. I mean, any suggestions on that?
That's a geological solution of accumulation. I mean, I think that's historically a lot of pollutants that we've generated in our society, trace metals, organic chemicals that have ended up from our cities into our coasts. They're on the seafloor, and they've been accumulating, and some places, like for example, we sometimes dredge up material and we put it into a hole on the seafloor and cover it with less contaminated sediments. But that's, you know, the estuary, both our marshes and the seafloor, is sort of our natural filter. Probably nobody really likes hearing that, right? Because that's also the home for the organisms that we're eating and so on. But that is a removal process and it's unlikely that we're going to be, you know, vacuuming up the seafloor and cleaning it and putting it back down there. So, you know, I think that's nature. But one of the big concerns that I have is that the exponential growth figure, right, that we're seeing on the seafloor, there's really nothing being done to stop that, right? It's going to continue to exponentially grow. And the sediments are really kind of a mixture of young and old sediments. So the younger sediments are probably even higher concentration. The other big, you know, sort of scary figure for me out of Victoria's work was the picture of the Petri dish. Because you look at that picture, that was the material that came out of a dredge sample from Water Place Park. And it is like every color and shape and size of plastic that you can manage or imagine. So if you think about the efforts of, you know, we need to do a bottle bill, we need to do plastic bag bans, but it's broader than that. We need to find system scale approaches to manage what we're making and think about end of life of material. I mean, it's just fundamentally, because there is no stopping. Exponential growth is just that until we take some action. And so, yeah, it's a big challenge.
So okay, one last question. Here we go.
So most of a large fraction is the last 2 decades, right, of this exponential growth. But the population isn't changing that radically. So that means the plastic is taking the place of something else. What is the something else that it's mostly being displacing?
I'm not sure I follow. I mean,
Do you mean packaging that we used to package in other things? Is that what you mean?
I mean, packaging is one of the things that, I mean.
oh, I see what you're saying, in our society.
But it's not just packaging, right?
It's everything. That list of,
Bottles,
yeah.
I mean, has the number of plastic bottles increased over the last 20 years?
Yes. So what Victoria graphed she didn't show was the exponential production of plastic. Since, the film The Graduate in 1968, one word, plastic, we have seen exponential growth to where we are now of hundreds of millions of tons being produced. So, it's an uncontrolled system at this point, and yeah, anything you want to add to that? Yeah.
Yeah, I do think it just we've replaced everything in our lives with plastic products because they're cheap and they're replaceable and they're easy to carry around. And, we didn't used to do anything single use, and now we do. We have a complete throwaway culture. We're completely fine using something for 5 minutes and then throwing it away. And so I think it's just our personal consumption has just gone out of control. So even though the population in Rhode Island hasn't been expanding, we're using more and more plastic per person.
So I, for one, feel really hopeful that we have people like Victoria and J.P. on the case, and let's please give them a big hand. Thank you so much. And we have some honey from Pick Will for each of you.
Oh,
Thank you.
so nice.
In glass
Thank
jars.
you. Oh, that's awesome.
So thank you all for coming. I just want to let you know that next year, 2025, we have a really great slate of events coming up in our learning series. And Jill's here from our education committee, and we've been working on lots of different issues that I think will be of interest to you. So this is over and out for 2024, but we will have lots more next year. Thank you so much for coming.
Thank you. Thank you. Thank you. It was a pleasure.
Thank you so much.
Kept you here
It's really engaging. Hi, it's so nice to